Yes, all the students, our topic based upon the request we have taken the field effect transistor. If you see the last unit, you can easily score with this particular question, and other theory is comparison of BJT and field effect transistor. So with the application point of view, where we see the presence of the transistors, if you see a smartphone electronic chip contains billions of transistors. Entire computer motherboard is made up of number of transistors. So if you see the BJT, the main difference is BJT is bipolar and FET is unipolar. So the time taken by the FET to turn on and off is very less when compared with the BJT. The speed of operation of FET is fast when compared with the BJT. Therefore, everywhere we go for the unipolar transistor. Unipolar transistor, there will be only free movement of the electrons only if it is n-channel FET. So we are having the junction field effect transistor, which can be of p-type and n-type. So we are going for the n-channel junction FET. Everywhere, every company, every electronic device is using n-channel extrinsic semiconductor, because the speed of movement of electron is fast when compared with the speed of movement of holes. So p-channel material we are not using for the practical approach. If I want to design one new smartphone also, I have to take one n-type silicon chip. Okay. Now, what is this JFET? The FET. What is the construction? FET, field effect transistor, we concentrate on the name later on. FET practically contains an n-type silicon thin layer on which at both ends p-type silicon material is diffused. Basic construction of FET is, and FET contains an n-type silicon layer on which at both ends p-type silicon material is diffused. FET contains three terminals. One is source, the drain, and the gate. So source, drain, gate. What is the use of the source? Source terminal is used to create the movement of electrons. If it is n-channel FET, always source should be connected to the negative terminal. Drain terminal is used to collect the flow of electron, to attract the flow of electrons. Therefore, always drain is connected to the positive terminal of the battery. Gate terminal is used to control the flow of electrons. So, you can see we got three terminals. Now, when P layer is diffused with the N layer, so we know that P layer contains majority charge carriers holes, and here we are having the majority charge carriers electrons. When p-type and n-type are diffused together, there is a presence of the depletion region. You can see the depletion region here. So why this depletion region is created in this particular shape? Why it is maximum near to the drain and minimum near to the source? We say that since the drain contains high resistance region. So let us imagine a voltage source is connected. Now, one second. Yeah. So now you can see the drain is connected to the positive terminal and source is connected to the negative terminal. So explaining in the examination, you have to draw the diagram, and second diagram will be showing the movement of electrons. So electrons always, source is connected to negative. Electrons are having the negative charge, therefore they are repelled by negative polarity. They try to move from source, to drain. But always direction of current is taken opposite to the movement of electrons. Therefore, the arrow mark is shown. ID drain current is shown opposite to the movement of electrons. So why here, if you see, since the drain is connected to the supply here we are having the high resistance region. Therefore, here depletion region is maximum. So when p-type is connected with the n-type, maximum charge carriers cannot move from one region to another region. The immobile charges creates the depletion region. Okay. So FET application of DC voltage to the FET is called biasing, as you got in the syllabus. Application of pure DC voltage to the FET is called the biasing. When the FET is properly biased, with drain connected to positive terminal, source connected to negative terminal, electrons start to move from source to drain. Okay, electrons are moving from source to drain terminal. You can see in the animation here. Now everything is happening when the gate voltage is 0. Okay, when electrons are moving from source to drain, now the FET is on. When the FET is on, if you want to turn on any device, that device will be on. Imagine with the help of your smartphone, you are dialing a number. Whenever you are dialing a number, you are turning on, let us say the number is 10 digits. You are turning on 10 FETs inside the smartphone. So that is what the practically happening. So when you want to dial a number, you have to turn on the FETs. How many FETs? Here 10 FETs. So how to turn on the FET? Or what is a confirmation? So whenever the FET is on, electrons travel from source to drain. Once the electrons are moving from source to drain, we confirm that FET is on. When the FET is on, the device is also on. So we can increase the voltage here, VDD, external voltage. As we increase the voltage, what's going to happen? The flow of electrons increases. Okay, flow of electrons increases. And at one particular point, both the depletion regions will be in contact. That is called the saturation point. Yes, the same behavior of the FET can also be explained with the low values of the gate. Now let us say I'm applying gate voltage -1. Now you can see when the gate is on, the electrons flow also increases. Now you can see with the increase in the gate voltage, slowly the flow of electrons increases, and at one particular point, this is called the pinch off voltage. The voltage at which both the depletion regions are in contact and there is no flow of the current, it is called pinch off voltage. Okay, so this is the basic behavior of the FET. If you see the characteristics, this diagram and characteristics, when the gate voltage is 0, okay, electrons will take maximum time, and this, what is this? Electrons are moving here. Okay, electrons are moving from source to drain, and once both the depletion regions are coming into contact, the flow of current is entirely constant. It is entirely blocked. Okay, therefore it is everything is happening under gate voltage is 0. If I am increasing the gate voltage, what's going to happen? Very early you are going to create the depletion region, and if still I am increasing the gate voltage, it will turn on. Depletion regions will come in contact at very short period of time. So this particular curve, it is explaining the breakdown condition. No need to explain this one. So FET operation explains under linear or triode region and saturation region. So we'll see once again. So what exactly the FET? Same points you can write. FET practically contains n-channel semiconducting material on which at both ends two p-type materials are diffused. When p-type and n-type are diffused together, depletion region will be created. Depletion region will be maximum at drain terminal and depletion region will be minimum at source terminal, because drain is having high resistance because positive terminal is connected here. The main function of the source is to create the movement of electrons, and the main function of the drain is to attract the flow of electrons. So when FET is on, when we can confirm that FET is on, when electrons are moving from source to drain, then the FET is on. If the FET is on, then any device is turned on. So first operation, case 1, source terminal is connected to negative terminal, drain terminal is connected to positive terminal, and gate terminal is 0. Electrons start flowing from source to drain. Okay, this is case 1. When we increase the drain voltage to a maximum value gradually, let us say drain voltage is 5 volts, 5, 7, 9, 10. At one particular period of time, both the depletion regions will increase and come in contact with each other when gate voltage is 0. Okay, that region is called the pinch off region. So now let us see. Let us create So I'm increasing the drain voltage first. Both the depletion regions are increasing and they are in contact. Now you can see that graph, why it was like that constant. Initially current was increasing. Now same behavior I can create very early if I am applying VG gate voltage as -1 volt, 2 volt, 3 volt. Very early you are going to turn on the FET. That is the saturation region is created. So this is what you can write for the FET explanation examination. You can draw the circuit diagram 3 to 4 times explaining different conditions followed by this graph. Okay. Now let us move to the full bridge rectifier, which is the easy and important one. So bridge rectifier, everybody know the circuit. Yesterday also I was saying that it is in the form of bridge, but the same circuit can be redrawn in this particular manner. You can redraw the same circuit as shown in this particular diagram. Now, for how many diodes bridge? 4 diodes. We are having the transformer. Okay, so you can connect the load. So I want to convert AC to DC. Rectifier is an electronic circuit which converts AC to DC. So how many diodes? If today only you can open your cell phone charger circuit. If you open your cell phone charger circuit, you will see the transformer and 4 diodes, black color one, old type. Okay. Now this RL is nothing but your resistor load. We can say you can even place the cell phone here for charging. Right. So our aim is to explain the full bridge rectifier. So the bridge shaped circuit can be redrawn like this. It is the easiest form. You will get the complete marks. No need to hesitate. D1, D2, D3, D4. So here, assume this is a terminal A. Positive is A, negative is B. During positive of cycle, A is greater than B. Therefore, direction of the current starts from the A. So same A and B written here. A, B. Okay, what is the explanation? How to explain the bridge rectifier? The current flow is important. So during the positive off cycle, first positive off cycle will be there. So I'll play the animation also. During the positive off cycle of input supply, voltage at point A is greater than voltage at point B because A is indicated with positive off cycle and positive off cycle is increasing in upward direction. Therefore, direction of the current starts from the point A. See all of you, if the current enters the anode terminal first, then the diode is on. If the current enters the cathode terminal first, then the diode is off. Note this explanation, I challenge you, you will never find in any textbook. It is the easiest and practical one. If many people, if you are just writing the same answer, let us say you are taking from the spectrum, you will get the average marks only. New explanation is what the examiner is required. Now, during positive off cycle of input AC supply, voltage at point A is greater than voltage at point B. Therefore, direction of the current starts from the point A. Now, how to confirm the diode is on or off? If the current enters first the anode terminal of the diode, this is anode, this is cathode, then the diode is on. If the current enters the cathode terminal first, then the diode is off. So if you see current when it starts at point A, it can reach D1 or it can reach D4. If it reaches the D4, D4 will be off. Yes or no? Because the current is entering the cathode terminal. Therefore, D4 is off and 100% of current flows through D1. D1 is on. You can see in the animation. We must write the direction. Current starts from A dash D1. You can see the current direction. Current flows from A to D1. Now D1 is on. Yes, this directions you have to show. 3 to 4 circuits you will get. Then only you will get the complete marks, not for the theory. Current flows from D1 to the, see if current flows to D3, it will be off. Therefore, it is off. So only D1 is on. Current flows through the load or resistor, and from resistor to the current flows through the D2. And from D2 current flows to the point B. So what is the answer explanation you have to give? Direction of the current is from A to D1, D1 to resistor, resistor to D2, D2 to the point B. Finished. Positive cycle. Okay. Now in positive cycle D1 and D2 are on. Now we go for negative off cycle explanation. It's very simple topics. Okay. Just listen the video. You will understand. Same points you can write. Now we are going for negative off cycle. During negative off cycle, as negative off cycle is increasing in downward direction, During negative half cycle, voltage at point B is greater than voltage at point A. Therefore, direction of the current starts from the point B. That current can flow to D3 or D2. Okay, at same instant of time, it will flow to D3 and D2. So if it flows through the D2, which terminal it is entering? Cathode. Therefore, the D2 turns off. And now 100% of current flows through D3. Now you can see with the animation, during negative half cycle, voltage at point B is greater than voltage at point A. Therefore, direction of the current is starting at point B. Now that current flows through the D3 and from D3 to the load and from load to D4 because already D2 is off. Okay. And it flows through the A. It flows through the A. It will not flow through this one. It flows through the A. So D3 to load, that is resistor to the D4 to D1. This is finished. So that's why you are getting, since the current flowing through the load, see this is the input, this graph is important for full bridge rectifier. Okay, input AC supply. So during positive half cycle, D1, D2 are on. Okay, therefore this is the explanation. During negative half cycle, the current is DC current. During negative half cycle, D3 and D4 are on. Okay, but why we are getting the axis above the horizontal line? Because the flow of current through the load is in same direction. So here also it will be same. These two graphs you are going to draw. Just draw the input voltage, output voltage and the current. That's enough. No need of this rectangular one. Okay. Now, you see all of you, in the syllabus also it was mentioned, rectifier with filter. Examination, if they are asking explain full wave rectifier with filter, capacitor filter or inductor filter. Always capacitor has to be connected in parallel. Write the previous explanation what you have written for bridge, the same circuit. Okay, this is also midpoint, the same explanation. Right. On your request now, if you require midpoint also, I will take separately. Okay, now. So what this capacitor will do, we require, you can see here input is AC, we require pure DC. But after the rectifier circuit, we will never get pure DC, we will get positive, we will get pulsated DC. So capacitor, what it will do, capacitor will pass freely the AC current and stops the DC current. So the pulsated signal, same word you can write, the pulsated current, which is the output of rectifier, the pulsated current, which is output of rectifier. This is pulsated current, you can see this one, just I'm indicating. The pulsated current, which is output of rectifier, contains AC current and DC current. That AC current is transferred through the capacitor and remaining DC current is transferred to the output or load. So now you can see this is almost equal to DC. Simple explanation, that's enough. Capacitor passes freely the AC current through it and it stops the DC current. Output of filter, output of rectifier is the pulsated signal, which is a combination of AC current and DC current. So AC current flow through the capacitor and remaining part of DC current will flow through the load. That's why we are getting this output. Similarly, inductor is always connected in series with the load. Same circuit, remove the capacitor and place the inductor. Inductor is connected in series with the load. Capacitor is connected in parallel. So what inductor will do? Inductor passes freely DC current and stops the AC current. So when inductor is placed here, unwanted AC current is blocked and DC current, required DC current is transferred to the output. Okay, that's enough here.